Test, test. All right, so I'm going to get started with the review of radicals that is due tomorrow on Classroom. Okay, so if you have any additional questions after I go over these two, let me know. Okay, so I'm going to go over two requested problems, which were 4A, which is this problem right. I'm sorry, 4A, which is this problem right here, and then 5A, which we'll do right after. Okay, so starting off with 4A. Hey, here is your problem. Okay, so just the directions aren't posted in here, so I'm going to read them real quick. It says just simplify each expression. Okay, so these are radical expressions. Okay, and we said a few things have to be true for radicals to be simplified. So I'm just going to type it out over here, so you don't have to read my terrible writing. Okay, we said there can be no perfect squares under a square root. Okay, because this one's square root, so I'm going to specify it for that. Okay, there can be no fractions under a square root, okay, under any radical really, and there can be no radicals in the denominator. Okay, so if these three things are true, then we can check the box and say this is a simplified radical expression. Okay, so right now you can take a look at this problem and see several issues. The first one is 200 definitely has a perfect square in it. Okay, x cubed has a perfect square in it. In the denominator, y to the fifth has a perfect square in it, so lots of problems with that first one. There are no fractions underneath the radical, so we're fine there, but there is a radical in the denominator, so we have to fix that. Okay, so here's how we're going to fix this one. Okay, there's a couple of ways that you can do it. Like we could start off by rationalizing the denominator and fixing that. We could start off by getting the 100 that's in 200 and removing that, right? Here's what I'm going to choose to do instead. Okay, so the first thing I'm going to do is remember that most of our properties of radicals, right, that we're using are reversible. So I'm going to reverse one of them. We typically, let me kind of give you a quick example. If I have something like 2 over 3, I'm allowed to break it up into square root of 2 over square root of 3, right? I can take a fraction, okay, that's under a radical, and I can split it up so the numerator and denominator separately have their own radicals, okay? And so I'm going to reverse this, right? Our problem already has it split up. I'm going to, like, unsplit it, right? I'm going to put everything back under the same radical. So I'm going to start off for this problem here and say that if I take the entire fraction, okay, 200 x to the third y, and 2x y to the fifth, and put it all under one radical, I can do that because I'm just reversing the property that we just see right here. Okay, so by doing that, I create one fraction that I can simplify. And that's what I'm trying to do. Okay, so I'm going to now look at this and say, hey, look, 202, that simplifies, right? So instead of dealing with two separate radicals, and instead of dealing with, rationalizing this big expression 2xy to the fifth, right, I'm choosing to just simplify it as much as I can before I deal with all the radical stuff. Right, so for this problem, I can say that the 200 and the 200 and the 2 will cancel and just make a 100, right, over 1, right, which I'll write for the sake of seeing it, okay? I can say these three x's on the top and one of the x's on the bottom will cancel. So if I cancel out this one, I can cancel out 1 on the top, and that'll leave x squared, okay? And then I can do the same thing with the y's. This one y on the top will cancel out one of the y's on the bottom, and it'll leave y to the fourth behind, okay? And all of this is under a square root symbol, okay? So that's still sitting there. Okay, I'm going to get rid of this 1 now because we don't really need it, but I just wanted to show you that 200 over 2 became 100 over 1. Okay, so this is our problem now, which is definitely simpler, right? I only have x's on the top and I only have y's on the bottom, so now I don't have to do as much work when I'm actually fixing the radical. Okay, so now I'm going to split this up, right, into two problems. I'm going to kind of take it back to where we started at the beginning and say this is 100x squared over y to the fourth, over the square root of y to the fourth, okay? And if you take a look now, things just became a whole lot easier, right? So I'm going to get rid of this thing. Right? We'll make it a little smaller, okay? And now, if I take a look at everything that's left over, everything is a perfect square, right? The square root of 100 is just 10, okay? The square root of x squared is just x, and the square root of y to the fourth, remember we just divide that exponent by 2, right? That's going to be just y squared. Okay, so there's actually in this problem no need to rationalize the denominator. There's no need to break out the 100 and split up the x and split up y, right? You could do all of that if you wanted to, but you're going to have a lot more work than just trying to simplify the fraction as much as you can to start, right? And then it actually ends up, conveniently for this problem, being a lot easier problem to solve. Okay, if this happened to have been like a y to the third, we might have had to do a little bit of rationalizing, but y to the fourth makes it a lot easier. Okay, so that's the answer to that one, 10x over y squared, right? Nothing else left to do there, right? Because we did our simplifying ahead of time. Okay, so if there's any questions on that one, anything that we did, or if you want me to see me do it a different way, maybe where we simplify everything separately and the more complicated version of it that you might have done, we can look at it that way too. Okay, so that's problem number 4A. Okay, this is problem number 5A. Okay, so 5A, the directions are a little bit more involved. It says simplify each of the following, then convert your answer to radical form. Leave your answer in simplest radical form. Okay, so this is not radical form. This is in exponential form, right? We have an exponent in our problem. So our job is going to be to convert this into a radical, and then take a look at our radical. And if that radical happens to not be simplified, we also have to simplify it when we're done. Okay, so the first thing we're going to do with this problem is realize that everything we talked about with radicals had fraction radicals. This is a decimal. So the first thing I'm going to do for this problem is take my 1.5 and turn it into a fraction. Right? 1.5 as a fraction is 3 over 2. Right? So I'm going to make this 3 halves. Okay. And now we're going to do our conversion into radical form. And just to remind you about that, because it's been a little while, right? We said the denominator, right? If I split this up into 2 parts, if I put the denominator on the outside, I'm going to say x cubed, okay, to the 1/2. Okay, and I'm going to do this a different way as well, so you'll see it 2 different ways. Okay, if I break it up like this, the 1/2 means the square root. So this is really the square root of x cubed. Okay, so this is now turned into radical form. The only thing that I have to do now is make sure it's in simplest radical form, and this is not because 3 has x squared in it, right? X to the third has an x squared in it. So I can actually break this up into the square root of x squared and the square root of x to the first, right? There's my 3 x's just broken up into 2 parts, right? And now I can break this one up and say that's the square root of x squared is just x, right? Not under a radical anymore, right? And then I have the square root of x left over. So this is my simplified radical expression, okay, with the x cubed taken out. Okay, so that's one way that you can do this problem. Here's a slightly different way that you might handle the same problem. Okay, I'm just going to go from this step right here. Okay, instead of dealing with all this radical stuff and having to do the simplifying in radical form, we can also do this in fraction form. We can say x to the 3 halves is the same as x to the 2 halves times x to the 1/2, right? So if you notice, if I add these exponents, I get my 3 halves back, so I'm allowed to do this, okay? And 2 halves is just 1, right? So this is just x, right? And then x to the 1/2 is the square root of x, okay? So this is an alternate way. It's not better or worse, right? We're actually doing the exact same thing. If you notice, here I broke up here's my kind of 2 halves, and here's my 1/2, right? So this step right here and this step right here are exactly the same thing, right? I'm just doing it a different way. So this is something where you could say, whatever your preference is, use that, okay? But in either case, we're getting our answer, okay? So this was, again, 4A on the review, okay? And this one is 5A on the review. So is there anything else besides 4A and 5A that we want to go over? And I'm actually going to look at it and see if anything pops out at me. I know we already went over, I believe on the last live stream, 6A. Yeah, 6A we did. And a lot of the other stuff we've covered previously. So I don't know. I know that the top group about transformations and all that might be a topic of concern for some people. That's typically, transformations are always a topic of concern. So if you have any questions about that, just let me know. Post them into the chat. Okay, and I will be here for any additional questions that you want to go over. Okay, while people are doing that, I'll just, if you're listening, just kind of recap some of the stuff I put into your classroom in the last couple days. Okay, so the district finally came out with the updated work from home guidelines for us. So I have to change what I'm doing a little tiny bit, not a whole lot. And the things that I'm changing are basically this, is that everything will be posted on Monday. Okay, so that's today. So you'll get every week that we're doing this, you'll be getting 2 assignments. So you'll get assigned 2 videos, and with those videos, there will be a practice that is not due, but again, just like we've been doing, just to give you a chance to practice your work. Okay, and then there will be a key provided with that, so you can check to see that you understand it, or to ask some questions about what you don't understand. And then every Wednesday and every Friday, we're going to have the live stream, which is the day that those assignments will be due. So I'll do if you think about it as like the video being Tuesday and then the assignment being due on Wednesday, and then there'll be another video that you can do on Thursday, and then a final one that a worksheet that you'll hand in on Friday. That's the kind of like the plan going forward, which is very similar to what we've been doing, but it'll just be on a like more 5-day schedule. Okay, and then I'm always available via email if you have any questions about any of that. Okay, so I think that's everything so far. Right, and I don't have any additional questions, so hopefully you were able to complete most of this review. Okay, so I'm going to mute my microphone, okay, and I will be here for probably the next 30 minutes or so. So if you have any additional problems on the review or anything else that's been due that you want to go over, just post it into chat, and I will continue to go over that stuff. Okay. Okay, 5C. So this was the question that just came into chat. All right, so 5 part C. So the idea with 5C is before we can turn it into radical form, we have to first uh, put these 2 t's together, right? So the way we put together the t's, just again to remind you about some of the stuff without the fractions, if I gave you like t squared, okay, times t to the, I don't know, 7th, right? The way we put these 2 t's together, if they have the same bases, we add the exponents, so this one will become t to the 9th, right? So we'd like to do the same thing here. We'd like to put together 2/3 and 3/4. So off to the side, here's 2/3, okay, plus 3/4, okay? And in order to put these together, because they are fractions, we have to find common denominators. Okay, so the common denominator for 3 and 4, I think we all know, is 12. Okay, so I'm going to turn these both into 12s. Okay. And so if I do the first fraction to turn it into 12, I'm going to do times 4. So that means that 2 has to be multiplied by 4. Okay, and then on the other side, same thing, times 3. Right, so the top will be times 3, and that'll be 9. Okay. So that's going to make this look like 17 over 12. Okay. And so if I add these two, if I multiply these 2 t's together, when I add the exponents, I'm going to get t to the 17/12. Okay. And so that's going to be my answer, right, in exponent form, but I have to turn it into radical form. Okay. So very similar to what I did with this one. I prefer strongly this way, because I'd rather not have to deal with all the radicals. So what I'm going to do is I'm going to split up my my 17 t's into 12 of them and the extra 5, right? So if I break this up into t to the 12 over 12, okay, and then t to the 7 over 12, 5 over 12, right? That makes my 17 that I have right here, right? Well, 12 over 12 is just 1, so this is just t, okay? And then the 5/12 I can break up, right? Which I'm going to kind of just do, again, a little side thing. I'm going to say t to the 5/12 is the same as t to the 5th being raised to the 1/12, okay? And then the 1/12 is really the 12th root, right? So I'm going to turn this one into radical form by making it the 12th root, okay, of t to the 5th, okay? And so this is now in radical form. I know it's simplified because I would need more than 12 t's to be underneath the 12th root in order to simplify that anymore. So I'm going to say that would be as simple as that one gets, okay? So again, if you turn this into a radical right here, you just have to break it up into the 12th root of t to the 12th and the 12th root of t to the 5th and then simplify like that. So you can do it that way if you want, but I think breaking up the fraction is a little bit easier, okay? So again, any other questions that we want to go over, please let me know. I will be here. All right, 7a. Let me grab that one. 7a. Oh, there it is. So 7a is a rationalizing the denominator problem, which is probably going to look terrible with me having to write all of it, but we'll give it our best shot. Okay, so here's 7a. Okay, the directions for 7a are to rationalize the denominator. Okay, so rationalizing the denominator just means get rid of the radical, right? We don't want any radical in the denominator, okay? So for this type of things, and I gave the hint in the directions, conjugates will be necessary. And the conjugate of the denominator is going to be root 3, okay, minus 1, right? If that's the only thing that we change for conjugates is whatever the operation is, we just do the other operation, okay? So I'm not going to even write anything else. I'm just going to simplify this. Okay, again, we'll do a little bit of work off to the side. I can do it down here. Root 3 plus 1, okay, times root 3 minus 1, okay? If I multiply all this out, here's what I get. Root 3 times root 3 is root 9, which I'm just going to write as 3. Root 3 times negative 1 is negative root 3, okay? 1 times root 3 would be plus root 3, okay? And then 1 times negative 1 would be negative 1, okay? So this is exactly what I was hoping would happen. Negative root 3 and positive root 3 cancel. And now this just says 3 minus 1, which is 2. So the denominator just becomes 2, okay? But here's the catch. Okay, if I multiply the denominator by root 3 minus 1, I have to multiply the numerator by root 3 minus 1, okay? So I have to do kind of this thing again, but with these two expressions instead. So if I do that over here and say root 5 plus 3, okay, times root 3 minus 1, okay? This one's not going to work out as nice, but we don't care. We just care that the denominator worked out nice, okay? So root 5 times root 3 is root 15, right? We said multiply what's under the radical. Root 5 times negative 1 is negative root 5, okay? 3 times root 3 is just 3 root 3. Can't do anything with that, okay? And then 3 times negative 1 is negative 3, okay? Guess what? None of these things go together, okay? I can't simplify root 15, okay? And I have 3 radicals that are not at all like each other, okay? And I can't make them like each other. And the rule for adding together and combining like terms is if I have a situation like this where they're both root 3's, I can do something, but these are all different. So I can't do anything with that. So I'm going to say, here's my answer. Root 15, okay, minus root 5, plus 3 root 3, minus 3. But it's all over 2, which is a nice non-radical denominator, and that's what we're going for. As long as we have that, we are good to go. Okay, so I can't really do much more than leave those 4 separate pieces together, right? And now I'm done, okay? All right, any other questions that we want to go over on the review sheet that is due tomorrow? Oh, I have a question that just came in. 2 on the review sheet. I'm monitoring my classroom as well. Okay, so number 2, okay. Okay, so number 2 is actually 2 parts. So I'm going to do one of them and I'm going to leave the other one for you to do. So I'll do 2A, right? Because what number 2 says, which I have to pull it out in pieces, okay, is to take a look at what's going on in problem number 1 and to solve it when y is equal to 10. Okay, so I'm going to pull out problem number 1A. So this is 1A, right? And number 1 said, state the domain and range, list transformations, do all that stuff that we talked about in the graphing section. Okay, what number 2 says is use each of the problems above. So I'm using letter A. Okay, and it says solve when y equals 10. Okay, so for this problem right here, I'm just going to remind myself up top that y should be equal to 10, right? And so that means that I can take this and I can put it wherever y is, right? So I can say that instead of writing y, I'm just going to put a 10 here. 10 equals the square root of x minus 1 plus 2. Okay, and now my job is just to get x alone, and we said the way that we get x alone is to try to get the radical, try to get whatever has x in it by itself, and I'm going to start off by subtracting the 2 to the other side. So it's going to be 8 equals, okay, the square root of x minus 1. Now that the radical is by itself and there's nothing else floating around on the outside, I can say let's take this and square it, which means I'm going to take the other side and square it as well, right? And that's going to be 64, okay? And then squared and square root cancel, so that's just x minus 1, okay? Add the 1 to the other side, and I found out what x is. It says solve when y is equal to 10. Well, there it is, 65, okay? Remember, we do have to check for extraneous solutions, but all I really care about is that when I plug this 65 in here, that I get 10 back. 65 minus 1 is 64. The square root of 64 is 8. 8 plus 2. Yep, that does give me y is equal to 10. So that one's a good answer, right? So the same thing's going to work for letter B. You just have to be a little bit more careful with that negative sign that's out front. You have to divide away that negative. And then I believe that one is extraneous. So be really careful with that one. Because when you get to the step, actually, let me just show you. We'll do it. Why not? Okay. So for letter B, it says, let me snip it real quick. Okay. So you can see these two side by side. And this one is only going to be like 2 steps, and then it's really fast. Okay. So here's letter 2B. Okay. And here's the difference. Okay. Actually, you know what? This one might still work. Yeah, it actually will still work. Let's see it though, okay? So for this one, I'm going to do the same thing. It's saying when y is 10, okay? So I'm going to plug in a 10. Negative root x plus 3 minus 1, okay? So I'm going to get my radical alone, which is this x plus 3. Add the 1 over first, so that's 11, okay? And now I have to get rid of this negative sign before I square it. I'm seeing a lot of people, like, even when there's a number here, that are squaring, like, once this plus or minus is gone. Everything has to be gone. So this negative sign, I'm just going to say, like, divided by negative 1, because there's technically a negative 1 there, okay? So if I do that on both sides, I'm going to get negative 11 equals, okay, the square root of x plus 3. So this is the step that made me question whether or not this is extraneous, and we're just going to see whether this works together, okay? And yes, Annie, I will go over 6a as well. Okay, so at this step, I'm looking at it. I'm saying, okay, the radical says the square root of x plus 3 equals negative 11, and that's not true, right? I can never square root x plus 3 and get a negative 11. So this is what's making me think it has no solution. But let's check, okay? So I'm going to square both sides. So I'm going to square, and on the other side, okay, I'm also going to square. So this now says 121 equals x plus 3. Okay, and then I'll subtract the 3 over. X is equal to 118. Right, so it looks like my answer is 118. So let's just check 118. Okay, so if I plug in the 118, this says the square root of 118 plus 3, which is 121. So this says negative root 121 minus 1. Well, root 121 is 11. Okay. This is now going to make it negative 11, so it's going to say negative 11 minus 1, which is negative 12. We just said y was equal to 10, right? So that means negative 12 is not equal to 10. Yep, it looks like this one's extraneous. And again, the step that kind of hinted to me that this was the case was this one right here, right? I had the square root of x plus 3, which is always going to be positive, is going to equal negative 11. which is something that can't be true, right? So you can see that in this case, because of that negative sign, right, we're going to get an extraneous answer. Okay, so that's the idea with letter B. Okay, so this is number 2 in its entirety. Okay, and then let's check 6A. Okay, so 6A. Okay, so solving this one. Okay, we did go over this one on the last live stream, but let's go over it again because it's a pretty intense problem, so it's worth going over, I think. Okay, so this is solving, okay, this ugly looking thing. Okay, so we said for a problem like this, let me just kind of recap solving for you. Okay, sorry, I'm trying to bring up my chat again. Okay, so we said for for any type of solving, the goal is get the radical alone. Okay, once the radical's alone, you can square it away, and your goal is to get rid of all the radicals so that you can get x by itself. Okay, this is a strange problem where there's radicals on both sides, right? So I can't get just all of the radicals alone. I have to deal with them separately. And so I'm going to look at this problem and say this thing on the right, the square root of 3x plus 2, is already alone. There's nothing on the right-hand side of the equal sign. So I'm going to start off by just saying, you know what, let's square this radical away. But when I do that, I'm going to have to take this entire left-hand side and square it as well. Okay? So here's what ends up happening. On the right-hand side, something nice happens. Square root and squared cancel, and I just get 3x plus 2. Okay? 3x plus 2. There we go. The left-hand side, however, is not all that nice. So I'm going to have to do my side work over here, right, and say root x minus 3, okay, times the other root x minus 3, because that's what square means. It means multiply it by itself, okay? So if I multiply this together, root x times root x is x, okay? Root x times negative 3 is negative 3 root x, okay? I get another negative 3 root x right here, okay? And then negative 3 times negative 3 is plus 9, okay? And then these two middle terms here, the negative 3 root x and the negative 3 root x, they don't cancel, but they can be combined because they are both like terms. They both have root x. So here's what I'm going to end up with. We're going to say x minus, okay, and then negative 3 minus 3 is negative 6 root x, okay, and then the plus 9, okay, is right here, right, plus 9, okay. So that's my first step. I got rid of one of the radicals, okay, and then just the left-hand side did whatever it did, okay. Now my job is to get rid of this second radical. I don't want any radicals, so now my job is going to be to get this one alone, okay. So to start off, I'm going to get rid of the easy stuff, which is this minus x, or this x is going to go away with a minus x, so on the other side I'll do a minus x as well, okay. And this plus 9 is also going to go away by doing minus 9, okay, so I'll do a minus 9 over here, okay. So here's what I end up with, okay. The x cancels, and I end up with negative 6 root x, okay. The 9 cancels, that's what I was trying to do, okay. And so here's what I'm left with on the right-hand side. 3x minus x is 2x. 2 minus 9 is negative 7, okay. Now, if I divide away the negative 6, okay, here's where if you were surprised that there was no solution, maybe it'll make a lot more sense right here, okay? So I'm going to cancel out these negative 6's, and it's going to say root x equals, okay, 2x minus 7 over negative 6, okay? Maybe it's not entirely obvious, but here what I'm looking at is this is a positive radical, right? Every time I square root anything, the answer comes out to be positive, okay? On this side, I have a fraction that's negative, okay? So it's possible, depending on the x values, that you might end up with a negative on this side. Let's finish solving it, though, and it'll be a little bit more obvious, okay? But this step right here is kind of making me look at it and say I have a positive on the left and I have a negative on the right. Maybe something weird's going to happen, okay? But we'll finish it anyway, okay? So if I get rid of this final radical by squaring it away, I then just have to square this whole thing, okay? So the left-hand side is just going to say x, okay? And the right-hand side, the denominator is simple. Negative 6 times negative 6, right, because I'm squaring it, will be 36, okay? And then 2x minus 7 times 2x minus 7. I'm not going to write all that out over here, but you end up getting 4x squared, okay? And then I get, if I multiply these together, negative 14x, so I'll actually get negative 2 of those, so that's negative 28x plus 49, okay? And then, so this is my answer. I kind of I got rid of the bad stuff, right? There's no more radicals in my problem, but now I just have to deal with like, how do I solve this? Okay. So here's what I'm going to end up doing to solve this thing. If I have over 36, let's get rid of that by doing times 36 and times 36. Okay. So I'm really trying to just get rid of this fraction. Okay. And I end up with 36x equals 4x squared minus 28x plus 49, right? That's a lot nicer. Now let's subtract that 36 over to the other side, and I get 0 equals 4x squared minus 64x plus 49, okay? So that's my, like, the problem that I have to solve, okay? I'm going to be a little bit lazy, just because, again, I don't have to write it out. My initial instinct with a problem like this is to use the quadratic formula, right? You might be able to try to factor this or something. This, however, is not one that is going to factor. So here's my lazy step. I'll bring it over so you guys can see it. Okay, there's a website called Wolfram Alpha, and I just put solve in there, right? And it actually shows you the interpretation, right? It's saying this is what I think you meant to say, right? And that's what we had, right? So that's the problem that I'm trying to solve, right? So if I look at this, it's going to give me my two answers, and you have to be a little careful with how the answers are displayed because they're kind of doing it in a little bit of a different way. Okay, here's the decimal forms, right? I can click between those, right? This is the exact form, okay? So here's what this translates into. I'm going to kind of move it over to my other screen so you're not going to be able to see it for a second. So the answer that you end up getting with the quadratic formula is basically this. It's going to be 16 plus or minus the square root of 3 root 23. Oops. Plus or minus 3 root 23 all over 2. Okay? So that would be like the final answer to the problem. And that's probably where most people stopped. Okay? But if we look at the decimal form, we do still have to worry about extraneous solutions for something like this. Okay, so if I were to look at this one and say, here are the decimal, if I go to my calculator and type in 16 plus 3 root 23, get my answer divided by 2, right, you get two answers. Do the same thing for the minus. You get 0.81 about, okay, and you get 15.919, right? So those are my two answers if I type this into the calculator. Okay, if I go up to my original problem, and I'm going to get rid of the squared stuff so we can just look at it, okay? Here's what I got to check, okay? If I plug in 0.81, let me bring up my calculator, okay? You can see all my video games pinned there, okay? I was playing Farming Simulator the other day, okay? Let's go to my calculator, okay? That's how bored I was. I was playing Farming Simulator. All right, so let's type this in. So 0.81 is my first radical, so I'm going to go to this first step, and I'm going to type in 0.81, okay, hit the square root button, okay, subtract 3, okay, and it looks like I get negative 2.1, okay, so this, when I plug in the 0.81 answer, I get negative on this side, and remember that any radical, we always assume it's the positive square root, okay, so this answer is not going to be an answer because when I plug it in, it makes the left-hand side negative, okay, and it makes the right-hand side positive. And that's impossible to do, okay? Let's check the other one. Okay, if I do the same thing with the 15.19, which is my other answer, if I do 15.19, okay, and I take the square root of that, and then subtract 3, okay, I get 0.89. And that sounds good, okay? Let's check the same thing on the other side. I'm going to do, for the other expression, okay, I'm going to do 3 times 15.19, add 2, okay, and then I'm going to square root that answer. And I get 6.9, okay? So if you notice, on this side, I got 0.89, right? And on the left-hand side, and then on the right-hand side, I got 6.8. And those are not the same thing, right? So this answer is also not good, okay? So this is a kind of very strange problem. There's a lot involved with it, but if you're able to handle what's going on here, that's very good because this is a very challenging problem, okay? So both of the answers end up, when you plug them into this original thing, giving you things that don't really work out, okay? You're welcome, Annie. Okay, so is there any other questions, anything else on the review that you want to go over? And again, if you're just joining us, remember this is due tomorrow. This review, right? So make sure you post it. Don't skip problems. So if you're still having any issues as you're going through them today, send me an email. I'll be monitoring my email. But you are responsible in order to get the credit to go through and do all of the problems. Okay, that's kind of how I'm seeing that you actually know how to do this stuff. And then there are two videos that I posted yesterday. One of them, which I believe I called day 11, day 12 maybe, okay, whatever that new one about exponential functions, that will be due, its worksheet will be due on Wednesday, okay, and then the last one will be due on Friday. So we've entered the fourth marking period, as strange as it is. um, so keep on working through the stuff, and again, like, don't sell yourself short and just kind of go through the motions with this, because at some point there will be assessments this marking period, and I want to make sure you do well in these kind of strange circumstances. You still end up, getting the grade that you want to get. So if you have any questions, you're always welcome to send me an email or post something on Classroom. I'm monitoring all those places. And again, I'm going to be here for probably about another 10 or 15 minutes. So if you come across anything else on the review sheet that you want to go over, just let me know, and I will go over that one as well.